Hello class, it's just me, Mr. Wee. I'm just going to review some stuff from section 1.3 where we left off in class, so you can get a chance to kind of practice a little bit more, and then we're going to transition to, I'm sorry about keep going back and forth on this weird perspective view finder thing. But yeah, I'm going to go over some review stuff from section 1.3, and then it's going to transition to the two sections we couldn't cover in class, okay? So without further ado, let's go ahead and begin 1.3. So this is section 1.3 again, and then this is just continuing from notes from where we left off. So this is 4a minus 5 times 2a minus 9. You can pause this and try this on your own, and then unpause it, and then check back to see what Mr. Wee did. But if you've unpaused it, let's go ahead and try out the solution. So what you're supposed to do is you're supposed to take each number in this parentheses and then multiply it to both of these numbers in this parentheses. So how I would do that is I would just take 4a, make sure or have that be multiplied with this 2a and this 9. So 4a times 2a would be 8a squared, because there's an a and 8 being multiplied together. 4a times 9 would be minus 36, because that's a minus 9, 36a, don't forget the a. And now I take the 5 and the second number that's in the parentheses. Let me see if I can focus this a little bit better. Okay, the 5 in the second parentheses, and then just distribute it to the 2a and the 9 as well. So then that makes sure, that will ensure that every number so far is being multiplied to each other, if you think about it. Okay, so minus 5 times 2a would be minus 10a, and then minus 5 times minus 9 would be plus 45, because that's a negative 9 that looks like a negative 9, that looks like a negative 9, or a negative 5, and that looks like a negative 9. You multiply two negatives together, you get a positive. Okay, so if you take a look at all the numbers that you have here, you have to combine like terms. That means terms that look alike. What I mean by that is 8a squared might look like it's in the same vein as 45, but if you think about it, it's not, because a squared is attached to 8. 45 does not have any letters next to it, so you can't combine these two. But 36 and 10 both have a configuration where they have a singular a next to each of their numbers, so they can be combined. A squared is not the same as a, so you can't combine 8a squared and minus 36a. Okay, so you're going to end up having 8a squared, and then combine these two, minus 36 and minus 10a. Just imagine like a little beaker, a little cup of A's, and you have literally 36 different A's, and you have negative 36 A's. I guess these are negative A's, right? Let's just call these negative A's, and then it's a little weird diagram. Just imagine there's 36 negative A's, and then you add 10 more negative A's, and together you have minus 46 negative A's, or minus 46A. Okay, and that's it. That's your final answer for that. Okay, let's do one more practice problem, and then I'm going to lead you into the next video. Okay. Second practice problem will be a little bit longer. It's 2y squared, so we did need to go through this because you've never seen it this long yet. I think I gave you a pretty complex one in class, but maybe not to this complexity. So you do the same thing. You just take literally every number or every value in here, and then you multiply it to every value in here. So let's just attack this one by one. 2y squared times 3y squared minus 5y and plus 2. So let's see what that is. 2y squared plus 3y squared would be 6y to the 4th power. That's a y squared and that's a y squared. And when you multiply those together, when you multiply letters and their exponents together, when you multiply them, you don't add them. You multiply y squared to y squared, you add the exponents together. When you multiply the letters and their exponents, you end up adding their exponents. And then you just take the number in the front and multiply that together. So the 2 and the 3 make the 6. The y's come together, and then you add their exponents, so now you have y to the 4th. Okay, and then let's keep going down. So this times this is going to be minus 10y cubed. Okay, because y, and if it doesn't specify the exponent, that's y to the 1st power. So it's y. That's 1 plus 2 in the exponent, and then you just multiply the negative 5 and the 2, and that's minus 10y cubed. Okay, 2y squared times 2 is just simply plus 4y squared. Okay, because that y squared doesn't have anything to multiply to really, so it just remains y squared. Okay, we're definitely not done. That's just the first part. This is the first part. I'm going to try to do this in a different colored pen, so hopefully that will kind of help. This 3y will be multiplied to 3y squared minus 5y 2. Okay, let's add those now. 3y times 3y squared would be plus 9y cubed, right? 3y times minus 5y would be minus 15y squared, okay? Because they only have an exponent of 1 next to them, so you just add those together and you get y squared, okay? And then 3y times 2 is going to be plus 6y. And we're still not done. Normally we would be done, but we have a third term. We have minus 1. So this is a little bit trickier, but I'm not gonna draw the arrows, but hopefully you understand you have to multiply this -1 to this guy, and this guy. So -1 times minus 3, or just positive 3y would be minus 3y now, minus 3y squared, I'm sorry. -1 times minus 5y would be plus 5y now, okay? -1 times -5 again is positive 5, okay? And then the y doesn't have anyone to really multiply to in this -1, so we'll kind of leave that alone. -1 times 2 is just minus 2. Okay, so this whole thing is all one statement. Let's combine like terms. I like to go from left to right, so let's see if there's anyone that looks like 6y cubed or 6y to the 4th power, meaning does anybody have a y to the 4th power I can add to? Nope. So he's left alone. So my final answer will look like this, 6y to the 4th. Let's go to the next guy. 10y cubed. Does anybody else have a y cubed? Yes, I see this guy and this guy. So I'm going to point to them with my fingers here. Okay, right there. All right, so that's, I know that looks bad, but that's a y. That's not an x, okay? 9y cubed and minus 10y cubed. It's like adding positive 9 to negative 10. You're still going to have one negative left, and then you're going to keep so it should say minus 1y cubed, but you don't have to write the 1, okay? So we leave it like that. The y cubed stays the same, so when you're subtracting, adding exponents, they just stay the same, okay? When you're multiplying them is when you change the exponent, okay? So let me say that one more time. Just as a review, if you have a letter with an exponent, when you multiply them, you add the exponents, or divide them, you subtract them, but I'm getting ahead of myself. But if you add and subtract these exponents, like 10y cubed minus 10y cubed plus positive 9y cubed, the y cubed stays the same, okay? You just worry about the numbers in the front, right? Negative 10 and 9. Okay, let's go on the next one. So these two were alike. They're already combined. 4y squared, oh, I see, 4y squared minus 15y squared and 3y squared. Oh, there's a lot of y squareds. So let's do this one by one. Positive 4y squared minus 15y squared. Let's do that mentally in my head. That's negative 11y squared. Then I add, or if I subtract 3y squared from that, then that should be minus 14y squared, okay? So these guys have been combined, so I don't have to worry about them. Let's go to the next one. 6y only has 5y. That looks like it. So I add 6y and 5y. That's plus 11y, okay? And then negative 2 can't combine with anybody else, so that is my final answer, okay? So hopefully that makes for good notes, but hold on, before we leave, I have one more set of problems I want you guys to do that will continue on. I won't give you the solutions for it yet. I just want you to see what happens when you multiply it out and then you start combining like terms, okay? So this is x plus 3 times x minus 3. This is x plus 2 times x minus 2. So these are each individual problems, right? That's x plus 2 times x minus 2. I want you to try this one as well. 2x plus 1 times 2x minus 1. And then the last one's going to be x plus 4 times x minus 4, right? So try that out, work those out really quick. or you can just see what happens in the next video if you don't want to do the work. But I would recommend that you just at least practice. So if you want to see the solutions for this, go to the next video and then notice that there's a weird pattern of things that are kind of going on. Try to explain it in words. If you can explain thoughts in your head in words, it does lead to better understanding of things, like a lot better. So like me being a teacher, having to explain things makes me a lot better as a learner. It does. It really does. It's genuine what I just said. So work these out and then also see what happens too. The results are going to be kind of weird, but like they're all going to like kind of have something similar to each other in their answer. Okay, guys, that's it for now. Go ahead and go to the next video and we will continue from there. I'm going to go ahead and stop the video. Thanks for joining me, guys. You guys have a great day, evening, breakfast, anything, anytime you're watching this. Bye.